Hello and welcome to the class on estimation of repeatability by intra-class correlation method. Repeatability refers to the expression of the same trait at different time in the life of the same individual. For example, milk production in successive lactations and fleece weight in successive shearing. Repeatability can be defined as the regression of future performance on previous records. The genotype of an animal remains the same throughout its life, and this genotype is responsible for expression of a particular trait. But we observe variation in the expression of repeated traits. Now, since genotype is the same, the variation which we are observing is said to be affected only by environmental conditions. Repeatability can also be expressed as the proportion of total phenotypic variance for a trait attributable to permanent difference among the individuals. Today, we are going to see the intra-class correlation method of estimation of repeatability. The intra-class correlation method partitions the total phenotypic variance into between the component of animal variance and within the component of animal variance. The skeleton of ANOVA table is presented in this particular slide, and the components of variance such as within component of variance and between component of variance is estimated according to the formulas given over here, and the repeatability estimate is calculated with the formula between the component of variance divided by between the component of variance plus within the component of variance. With the help of a solved example, we will try to see the estimation of repeatability. Here, in this example, the lactation production of 10 buffaloes is given. We have to conduct the analysis of variance and have to estimate the repeatability of milk yield. Initially, we will have to calculate some basic statistics such as capital N, summation x square and summation x bracket square. The correction factor can be calculated with the formula grand total square divided by total number of observations. In this example, the correction factor comes to 666.51. The total sum of squares is calculated by taking crude sum of squares minus correction factor. The crude sum of squares comes to 836 and the correction factor is 666.51. Therefore, total sum of squares comes to 169.49. Now, the between component of sum of squares is calculated as shown in this slide, and it comes to 116.90. Now, within the component of sum of squares is calculated by taking total sum of squares minus between the component of sum of squares, and therefore within component of sum of squares comes to 52.59. Putting the values of sum of squares in the ANOVA table, we can find out the mean sum of squares. And based on mean sum of squares, we can estimate the components of variance. The between component of variance can be estimated with the formula between the component of mean sum of squares minus within the component of mean sum of squares divided by k, where k can be calculated with the formula 1 upon small n minus 1 multiplied by capital N minus summation Ni square divided by capital N. K can be estimated using this formula if the number of progenies are unequal. Here, in this example, since the number of progenies per sire are unequal, we are calculating K, the constant, using this formula to get a value of K as 6.91. Therefore, the between component of variance comes to 1.87. Now, the repeatability estimate can be calculated as 0.68 for this particular example. Based on this, there is an exercise as your homework. You will have to estimate the repeatability of number of services per conception based on the data given on 4 cows in their first 3 calvings. Thank you.